Hi, everyone. We are at the top of the hour. Thank you for joining us today. I'm here with Patrick Stasko, Solutions Architect for Rolta AdvizeX, and Patrick is going to be talking to us today about isolated recovery and data protection. One note for those of you that are on the live version of this webcast, there will be a code at the end of the presentation that you can enter to claim your Amazon gift card. So with that, I'm going to turn the presentation over to Patrick to guide us through. So remember to keep those questions handy for the end and be sure to write down the code when we get to the very end of the presentation. Patrick?
Jocelyn, thanks for the introduction. Like Jocelyn said, my name is Patrick Stasko. I've been with AdvizeX for 3 years as a solutions architect. I have over 10 years of industry experience, both within Sherwin-Williams Paint Company, a paint manufacturer here in Cleveland, Ohio, along with a medical software company where we hosted our software as a service. My background is very diverse. I have a deep core competency in everything data center pretty much. So that comes down with Dell EMC, compute, storage, along with networking from Cisco, HP, Aruba, Arista, and also a very deep development background. So as a former life, I was a C# and a Java developer, and I'm still very active in coding myself on the side. Below, you can see some of the certifications that I have there, VCP and Centric, TA, and Cloud Architect, just to kind of formalize some of the qualifications that I have. And some random fun facts is I'm married with 2 little kiddos, 2 under 2, so it's fun times. And generally, if I'm not doing this as my full-time job, I'm tinkering with a Raspberry Pi or some sort of code language. So with that kind of being said, before we really dive into isolated recovery and the data protection suite, it's really important to understand the brief history and the autonomy of ransomware. So if we go back in time to 1989, this was really the first ransomware that was identified. And this was a DOS platform. And this particular ransomware was transmitted from floppy disk to floppy disk. And an individual was required to mail $189 to a PO box in Panama to basically receive codes to unencrypt the files in a DOS-based system. This was really the first identified ransomware, and since then, over the years, there's been a growing amount of variants in different strains of ransomware, which we'll touch upon in a slide here in just a second. But kind of going through the evolution of ransomware from the DOS days to modern days, there's been some other interesting ransomware attacks that leverage different technologies in different means that traditionally haven't been considered. So the WinLock is really interesting, at least from my perspective, is this is kind of around the Windows XP days, and it would encrypt system files, and it would have an individual send a premium SMS text message, which would cost about $10 to go ahead and send a PIN to a number, which would then return another PIN to decrypt your files. And so this WinLock, it's estimated that over the course of its run of a couple of years, actually generated about $16 million. So there's a lot of stakes when we start to talk about ransomware and where it's going. And so when we take that $16 million, keep in mind that was, this is hard dollars. If we look back at the AIDS malware, an individual is mailing basically a mail order, and WinLock, you were leveraging, text charges with your cellular provider. And there was really a pivotal shift with ransomware somewhere around 2013, 2012, 2014. And this is really because of Bitcoin or anonymous payments. It's not that the payments are necessarily anonymous, it's that the attackers are able to obscure their true identity. And so with this kind of became the de facto platform of receiving payments. Since then, there's been a rise on the value of Bitcoin, both legitimate and illegitimate reasons. But this was kind of a pinnacle point within the ransomware technology stack of enabling basically malicious attackers on the black market to be able to sell and collect funds for their malicious code. And we fast forward over to 2016 to the K-Ranger malware. And this is kind of interesting because this is the first malware that actually targeted OS X. So when we look at malware, we're generally talking about Windows-based systems, and this is kind of a paradigm shift that this variant was targeting OS X, and this vulnerability was actually first founded by Palo Alto Networks. And so essentially what it did was it hid itself in another payload and used a legitimate developer signature to distribute its malicious code under. So the binary that the individual downloaded off the App Store was indeed legitimate, but baked in with a payload that was not. And so there was immediate fixes and releases, and I would suspect that you would start to see more and more variants targeting other platforms other than just Microsoft Windows. So this is a really interesting slide that F-Secure provided, which is a Finnish security company, which was originally founded in 1988. So they have over 30 years of industry experience in the security sector. And what really this slide is illustrating is they've been tracking ransomware and different variants of malware and cryptoware, before 2012. And over the years that they've seen a trend of over 6,000% increase, over 140 new variants in just 2016, with stakes larger than, I'm screwing this up again. All right, I'm pausing. So this is a really interesting slide. F-Secure provided this slide, which is a Finnish security company, which was originally founded in 1988. And they have over 30 years of industry experience within the security sector. This slide is really interesting because what F-Secure has done is they began tracking the individual ransomware strains throughout time. And as you see that it's been a growing threat, a real growing threat since the introduction of Bitcoin and cryptocurrencies, where there's 140 new variants alone in 2016. So that's nearly a 6,000% increase since F-Secure started monitoring what type of strains and variants of ransomware. So we know that it's a growing problem for organizations to keep on top of ransomware. It's a growing threat because there's large money at stake. But how does ransomware really work? So it's really pretty much a 5-step process, and as you see on the right-hand side, it's a really good illustration of how ransomware infiltrates an organization and how it works. So really the first part of it is really installation. So this can take place of one of two ways. One would be a downloaded file through a phishing attack. So this would be an email attack that looks like maybe a bank statement or some sort of information that you already received, but it's kind of deceiving that it's not exactly what it looks or appears to be. And then ultimately it would require the user to go ahead and click a link and download something malicious. That's one way. Another way is vulnerable code exploits. And this is more complex, and this is crafted and generally targeted against specific vulnerabilities in software. But after that, the code has been downloaded and ran and deployed, the second step is actually contact headquarters, and headquarters is kind of used loosely just because it's dynamic in nature when the attackers are targeting multiple systems. And generally, they use name servers that are really pretty much throwaway domains, generally to obscure the identity of where their operations is actually being conducted out of. There's generally multiple layers and multiple hops through servers all throughout the world to really obscure who's the controlling entity of the actual ransomware. But after HQ has been established, keys and handshakes are happening. And so really what that means is since ransomware in nature encrypts data, the keys are sent back to headquarters for the fifth step for extortion. So ultimately, after the headquarters and the malicious code on your computer or your servers have agreed that these are the keys, encryption then takes place. So in the background, generally, the software remains dormant, visibly speaking, until the encryption process has taken place. And so at that point, once all the files that it's designed to encrypt are encrypted, the fifth part is extortion. So generally, the typical price for a ransomware attack is anywhere from $300 to $500, and this is not necessarily a industry standard, depending on the strain or the variant, or if it was a very specific targeted instance of ransomware. This bounty for your encrypted data can greatly vary. So let's talk about the security framework with how we can help mitigate and prepare for a ransomware attack. So here at AdvizeX, we have a 5-step layered approach, the data-centric security model. And it really starts with data and then goes outward. So data, identity, network, platform, and governance. And data is about 80% of what I'm speaking with customers about. This is generally the regulated sensitive data that's meant to be kept secret. So this would be healthcare records, social security numbers, maybe patient records. This is generally the bulk, the GUI center of what attackers are trying to really attack and solicit against. Think of this as the recent Equifax hack, that most of the data for the individuals of the Equifax, and I think we're all probably pretty much affected with that type of security breach. This is what they were targeting. So these are about 80% of the conversations that here at AdvizeX that we're having is how do we protect the information that is meant to be protected. Then we kind of work out that way. The next step is identity, how you access this data. And that's really broken up into 2 parts. Authentication, which is who you are, and authorization, what you're allowed to actually get to. We work out to the network layer, which includes your typical IDS, IPS, your next-gen firewalls, the actual transit of transactions on the network. We move out to platform. At either end of the transaction, this is where security, hygiene, and endpoint security really live. So a true platform for end-to-end communication from client server and back. And lastly, governance. This is essentially what the business is telling what to secure from an IT perspective. Obviously, there's governance around regulated data such as HIPAA or PCI for financial data. These definitely take into play, but there are also a lot of other types of governance that fall within this category. So this conversation is a little bit larger than the conversation that we're focusing on, which we're going to primarily sit in the data sector, but with the following slides. And so the layered protection for DPS security really lives in that data layer within the previous slide. And so EMC really breaks this down into 3 different categories. We talk about the traditional data protection best practices, the hardening and protection features of DPS, and advanced protection services, isolated recovery with this type of model. It's likely that you have the best practices in place to some degree, and with the hardening and protection features, these are basically upgrades to your traditional data protection best practices, more of an applied approach. And isolated recovery offers a true off-wire protection. So diving into a little bit deeper on the traditional data protection best practices, it's suggested that NIST and FBI suggest that this alone is inadequate. And generally, these are the best practice guidelines of, how often do you change your passwords, not writing your passwords down, stuffing them underneath your keyboard, a variety of, don't click on links that you're not aware of, just overall hygiene. These are more operational based and require, human intervention and education, but there are some tactical IT perspective items within the best practices guide. But generally, this is around policy and procedure to much of the degree. So it's suggested that this is not sufficient enough. So we dive deeper into the layer. Hardening and protection features. When we actually go into the DPS environment, there's very tactical things to go ahead and harden and secure. I think that if you're underneath HIPAA governance, that you'll see this in a HIPAA risk assessment. These are very much things that you would find in an audit report. Inactivity timeout, deny consecutive login attempts, aging, SSL certificates, disabling unneeded protocols. This is just part of good IT hygiene from an infrastructure perspective. Diving deeper into the core, really what we're here to talk about is isolated recovery. How do we create a physically and logically isolated environment? This environment is secure in the sense that it's air-gapped from a network and a physical perspective. Data is copied over this air gap to an isolated environment that then we could use for testing, validation, and restoring. The real premise underneath this and behind this is that ransomware cannot encrypt what it cannot access. So this is why the air gap is so critical into isolated recovery. This air gapping mechanism provides a gap that ransomware cannot even connect to. And only upon replication on scheduled times that data is transmitted in a very isolated fashion from one data domain to another data domain. So with that being said, this has kind of laid up the groundwork for what is the isolated recovery. Isolated recovery really is broken down into 4 different steps. Arguably, the first one, the planning and design, is the most critical. This is the most important step. We're here to identify mission critical and business workloads that are critical to an organization staying online. This is the real data that we're trying to protect. This is very similar to a DR exercise. What are the business critical applications, and in which order do I need to fail them over? It's very true that this follows very similar guidelines to disaster recovery, that we need to identify these workloads and have a procedure and a process in place to be able to recover them in a timely fashion of an outage. And think of this as a little bit more of an extension of a DR strategy. And if you do have a current DR strategy that is relatively mature, the effort for an isolated recovery, you'll find a quicker time to actually being able to deploy one. So really understanding what's required to be protected from a business and an IT perspective is the most critical phase, the planning and the design. The rest kind of follow suit then after that. Once we define what we need to protect, really the second and third and fourth are how we are going to protect it, how we're going to validate it, and how we're going to restore if we really need to. So in the second phase, or the methodology, is isolation and replication. And this is what we talked about with the air gap. And we'll talk about the air gap more in the next slide, that this is a physical separation of 2 networks, an isolated environment, having a dedicated network link that's being enabled and disabled within the isolated recovery zone, and also disabling it when it's no longer needed. This is generally automated and scripted. And then after that, we kind of move into validation. When this data lands in the isolated recovery zone, how do we know that this data is truly the data that we need that's not already encrypted? So there is a process in place to regularly test and validate that the data in the isolated recovery zone is exactly what we expect it to be. Nothing would be worse than to have data in the isolated recovery zone and not have the ability to restore and rehydrate data that's not already been encrypted. So this is really the last fail-safe within an organization to restore their data. So the validation part on a regular basis, no different than DR hygiene, is very critical to the isolated recovery methodology. And lastly, the big red button, restore and recovery. We hope that we never have to go ahead and press that big red button and restore all the data back to the organization. But if it's required and we are hit by ransomware and our other mechanisms have failed us, we can rest assured that in this isolated recovery zone, that we have a sufficient copy at some point in time, relatively recently, that we can go back and rehydrate the entire environment from. So you're probably wondering, like, how is this any different than disaster recovery? Well, disaster recovery is aimed to minimize downtime in the event of a hardware or a logic failure. Generally, DR follows pretty closely to production, just in a physical separate location. So the idea is that if we have this other copy in isolated recovery, there's a longer time gap. But with DR, we try to minimize that time gap to get to near real time as production as possible. So with that is, the understanding is that if production is hit with ransomware, it can literally take, minutes 5 to 10 minutes to replicate to our DR site, effectively causing our DR site to be ineffective. So the idea is to have an isolated recovery zone, again, on more of a scheduled basis, relatively close to point in time as we possibly can, to be able to restore from. So how do we do this? At a high level, we have two basically data domain appliances. We have our primary storage array, and this isolated recovery zone that we've been talking about is over here in the center of the screen. We have basically a small replica of our primary environment. We have recovery hosts, validation hosts, management hosts, basically everything within this isolated bubble, and it's also physically separated inside the data center. That these are all the tools that we need to go ahead and rehydrate this data if all other systems are down and inoperational. And so really how we start this is we start with the isolated recovery system. And what this does is it controls that air gap process, that automation script that we spoke about in previous slides. What happens is that the systems inside the ISR, isolated recovery system, opens up the network port that's generally a dedicated link from a data domain to another data domain. There may be a series of switches, but essentially what happens is the network link is physically put in a down state. The first step is to bring that state up. The second step is to initiate that replication copy. And keep in mind with the technologies of DD-Boost and DD Replicator, these are differential copies that are compressed and deduped and across the wire. So they're very quick and very efficient after the initial seed. So subsequent copies is really just the change blocks and bits of data. After the data has been copied, which has been initiated from the isolated recovery zone, the air gap is then closed. So the network port is physically shut down in a port down state. Then we roll into the validation process. We perform a desired number of fast copy operations, and in a fast copy operation in the data domain world is really a copy of pointers. Since everything is compressed and deduplicated, we're copying pointers from one logical partition to another. So this allows us to have multiple copies. And the reason for multiple copies is we're going to go ahead and perform testing and validation against these copies so that we can verify that the data is truly intact and in place on a regular basis. And then number 5, the validation hosts. On automated validation routines, if there's a failure, let's go ahead and send an alert. Generally, there might be a single management host for egress for email access, just sending out within this that is not tied to your primary environment. So ultimately, this is what an isolated recovery zone really looks like. This is what isolated recovery truly is. Having everything that we need inside of a bubble in the event that we need to restore everything else. And generally, this is our last ditch effort for recovery. So we're going to take this a little bit further. We're going to actually do a little walkthrough with the isolated recovery framework. We're going to first start with the replication. We're going to go through the validation and then restoring an actual environment. So after the backup's run and complete, Avamar performs an Avamar checkpoint. And essentially what the checkpoint does, it says that, hey, this data, this backup is completed and it's scrubbed and cleaned and ready for replication. And so after the first data domain in the Avamar units have completed their backup jobs, what happens is the isolated recovery link is enabled. Again, generally this is dedicated. I've seen this as physical connections between two data domain appliances where we're actually controlling the port state of the data domain. Sometimes there's an intermediate switch. There's design considerations of how we physically connect these two links together. But generally, there is ACL rules specifically around from one replication target source array to the destination. So it is very much a peer-to-peer, ACL security firewall permission, if there are any, that only allow these two units to actually talk to each other. So in theory, Avamar instance on the left-hand side would not be able to talk to the Avamar instance in the vault. So it's truly isolated. The replication is initiated from the IR management station inside the recovery vault. begins moving the data from the production to the vault. And then subsequently after, the link is immediately disabled. Once the link is disabled, then we move into the validation phase. And with validation, we're basically checking that the data that we've received is what we expect it to be, not encrypted by some ransomware. We create a fast copy. Again, this copies pointers in the data domain. So the fast copy literally takes seconds, not the entire data footprint being copied, since we're relying on pointers that are compressed and deduped. So there is only unique data, and we're pointing back to different pointers. Generally, it's recommended to have some sort of retention lock. This is a feature set within the data domain appliances that allows locking of a entry, which is a logical partition. And this is what you're seeing here, kind of illustrated, is that we have different entries, which means really we have different partitions within the data domain. So what we're doing is we're creating a clone of the one partition that's write lock enabled. And so that means we can't actually change that data, even if we have root and administrative privileges. This adheres to governance to that the data actually has to age after a period of time before it can ever be deleted or modified. So this is very much in accordance with governance policies for e-discovery and other types of functions. So this has to age out. It cannot be deleted even with root administrator access. So essentially what happens is we create a copy of the data that's been replicated for testing and validation purposes. We present that as an NFS export or some other, we don't have to necessarily use NFS if we are using sys in the Windows world, or we are using one of the mechanisms or the protocols to validate this data. This scenario, we're using an NFS export, and we're mounting that on our management station. And what we're going to be doing is setting retention lock policies and validating the information. After that, subsequently, we unmount the export and remove the export. We know that this data that we just tested is exactly what we expected it to be. So with that, now we're going to go ahead and create multiple copies for maybe other additional testing. So now that we have the data, we went through the process of how we actually back up the data with replication. We've gone through the validation process. The last procedure to actually complete is how do we restore. So again, taking that retention lock enabled backup, we're going to go ahead and clone that and create an identical copy with the same name and same time, point in time copy of basically our other production site. And with that is what we're doing is we're carrying the data along with the Avamar instance that is identical in name as our production. And what this enables us to do is restore our entire backup set to a new location. So again, with that Avamar index data, we're restoring that back to an instance of Avamar. And with that, we're doing a rollback. And at that point in time, we have the management system to be able to restore backups along with all the index data and all the data that it actually backed up to within our vault. And at that point, we're going to rehydrate from this identical copy within the vault back to our main production systems. So whether this be SharePoint or unstructured file data, Exchange, SQL, VMware, we have an identical copy of our backup environment from production inside our vault as a last fail-safe ditch effort to restore from a ransomware attack. So really, in summary, the most important things about ransomware and isolated recovery really is in the beginning part of the educate and assess. The design and build really come naturally a part of the planning phase. So again, understanding what we're trying to protect, what's most business critical, what's most impactful to the business, what is the highest data sensitivity to an environment or to an organization is really what we need to plan against. This is no different than a DR strategy that we need to have a very solid understanding of business application and protection requirements. We need to have a plan in place that's a regular plan to go ahead and replicate, test, and validate that this plan, if we need to execute it, will certainly work. Then, once we have a very defined plan, the implementation will have various requirements of hardware and software, switches. There's other components that we would put from a design perspective inside the isolated recovery zone for different use cases. And lastly, again, going into the validate, really ensuring that when the data lands inside the vault, that is exactly what we expect it to be. This is really the big red button for an organization to press should they ever get hit with ransomware. And kind of with that being said, ransomware falls within the data protection suite from Dell EMC. And we're going to just take a quick couple moments just to really kind of go over the DPS suite here. It's been broken down into 5 different categories. DPS was originally founded as we know it today, is DPS for backup. When EMC originally came to market, it was just simply called DPS. And since then, there's been a lot more use cases and the portfolio has been expanded upon. We have the Enterprise Edition, which is all-encompassing. Backup is the traditional DPS licensing that we're used to. Applications is we have deep integrations into Oracle or SQL, basically DD Boost enabled backups inside the enterprise applications. DPS for VMware with virtual environments in the 90 percentile for organizations. There is a specific offering for heavily virtualized environments. And then DPS for archive. This is basically source one and e-discovery type of use cases here. And so what we're going to go ahead and do is kind of break these apart. Within these suites, again, talking about DPS for backup, we have a choice of software, both Avamar and Networker. These are 2 different products that coordinate backups within the Dell EMC portfolio. There's specific use cases for one or the other, but as a suite, you're enabled to use either one of them based off a capacity license for your organization. So generally, Networker has more support against big iron HPUX workloads or other architecture workloads other than x86. And Avamar is generally a better fit for more virtual style environments. And within each product suite, there's different things that are included. And I think the really big things to highlight here is the Data Protection Advisor. This is the advanced reporting with DPS, which you're able to integrate Avamar and Networker and other EMC products for truly a single pane of glass reporting engine for all things data protection. Cloud Boost gives us the ability to go ahead and have that elasticity into the cloud and out of the cloud to really make the most financially responsive choice of where to place backup data. DP Search gives us kind of a Google-like indexing that if we're looking for a file within a backup tree, essentially what it gives us the ability to do is type in the file that we thought it was called, and it would basically understand of where this file is backed up and when and where. So sometimes, generally, instead of seeking and browsing through backup jobs, whether it's a per day or per year backup, we have the ability to go ahead and index all the files within that particular organization. The other one that I'd really like to talk about is DPS for VMware. Again, with the majority of our clients being virtualized, what this includes is the Avamar Virtual Edition, and this licensing is per socket based, so very similar to the VMware licensing model of ESX or vSphere, so very similar. With that, we also have additional capabilities such as Recovery Point for virtual machines. This is a DR mechanism with journaling to provide DVR-like playback for virtual machines. Again, we have Data Protection Advisor, our reporting engine, and also DB Search, basically our indexing engine for DPS. Other ones to really kind of touch upon really quickly, Source One for email, SharePoint, and file systems. This is really geared towards e-discovery type of use cases. And also DPS for applications really quickly as well is what it really includes is Protect Point, which is a product that allows EMC products to leverage recover point splitters inside the storage arrays to basically have zero impact backup to a data domain. And so essentially it is fiber channel enabled for those fiber channel shops that have, a large investment in fiber channel, and basically plumbs journal and snapshots right directly to the domain to have basically the lowest impact on performance for workloads. And also with that is enterprise data copy management to really understand the dependencies between systems and storage arrays and just overall copy management. You can get all of this within the Dell EMC Enterprise Suite. So that's very encompassing of pretty much an entire organization. So regardless of size or where you're at, your DPS or backup strategy journey, there is a model that definitely is right, that can fit your business needs and requirements. So with that kind of being said, thank you for your time. Hopefully you have a little bit better understanding about what the isolated recovery is and what it means. And I'm going to turn it back to you, Jocelyn.
Thanks, Patrick. That was great. So we are just going to pause a second and ask people if they have questions to please go ahead and enter them on their screen. You'll see a panel where you can type in. You can send them directly to me, Jocelyn Philbrook, or you can just put them under the chat. And we're just going to pause for our first question. Okay, so Patrick, the very first question is kind of a softball here. So this person is interested in how they get started. So what is their next step if they're interested in taking this further?
Yeah, I think the best step is how to get started. If you already have a relationship with AdvizeX, is to kind of reach out to your account executive and kind of work the channels that way. I would direct you to the data-centric security model. That's a very good guideline that we use with a lot of our customers. Regardless of where you're at organizationally, whether it's size or makeup or industry type, this model is really a universal that we can really kind of talk and walk through it regardless of where you're at in your journey. So that would be within our security practice. This would be a really good starting place. If you're not an AdvizeX customer, you haven't worked with us, you can feel free to reach out to me, Stasko, Stasko @advizex.com. Or you can, go to advizex.com and go to the contact page and inquiry about somebody to reach out to you and contact you about ransomware or our data-centric security model would be my recommendation.
Great. Okay, so the next one's a little bit more technical. So, question here is that, so this addresses, DPS addresses part of the ransomware pane, but what about stopping malware before it lands or stopping ransomware as it tries to encrypt? Could you talk a little bit about that?
Sure. Generally, when we're seeing ransomware, it's very hard to stop the encryption process in flight, generally because the behavior of ransomware is silent until most of the files are already encrypted. There are tools that we partner with to identify security access to unstructured data, file shares, and now what we're seeing in the marketplace is tools that have basically intelligence to say, should Joe really be touching the finance data when he's really somebody in marketing, right? A very simplistic use case. It has intelligence that we're able to trend user activity and then alert or block based off of anomalies of that user activity. So that's one way to kind of prevent that. Again, I would take the data-centric security model because really this model covers, prevention from, whether it's a governance or identity network or platform. It's really a comprehensive model that we focus on securing the data, and then we work backwards from that. Who and who's allowed to access that data and who they are. How do they get access to those networks? What platforms are they using? Is there security, hygiene, and checkpoints in place there? And then we wrap it all around with governance. So really, I hate to give the same answer for two questions, but the data-centric security model is really truly a proven model for either response or prevention of ransomware security type of conversations.
Great. So we have taken all the questions that we have. So I want to thank everybody for joining us today. We really appreciate your time. You're going to see a code now on your screen. If you registered before today, please enter that on the registration form that you should have received via email, and you'll receive your Amazon gift card. If you have any questions, feel free to send us a note, and we'll be sure to respond back to you right away. So thank you again, everyone, and you can now disconnect your line.